So the very popular and the starting point of simple harmonic motion is simple pendulum. The very popular the system where the particle or a bob executes simple harmonic motion. We know that the simple pendulum consists of a bob of mass m suspended from a fixed support using a light string of length L. Let us say this bob is displaced by a small angle theta from its original position. Here L is the length of the string, m is mass of the bob. Okay. If I resolve the gravitational force mg into two components, this is mg cos theta. Mg cos theta is the force acting along the string. Mg sin theta is the force acting perpendicular to it and towards the mean position. So let us say O is the mean position. Of course, the tension in the string will act like this. Along the string, resultant force is T minus mg cos theta, and perpendicular to it, resultant force is mg sin theta. This mg sin theta is also called restoring force, which try to bring back the bob back to the mean position. So the restoring force F is equal to mg sin theta, the unbalanced force which is acting towards center. If I call this as displacement, which is in this direction, let y is the displacement of the bob from mean position. Since this mg sin theta is acting opposite to displacement, F is equal to minus mg. The minus sign indicates it is acting opposite to displacement. Displacement is towards right, acceleration is or force is back. For small angle, I can write theta. Sin theta is equal to theta for small angles. And according to Newton's second law, F is equal to ma g. We can take this for small angles, this is arc length. Y is equal to L theta. So theta is equal to y by L. So mm gets cancelled. So acceleration is equal to minus g by L into y. That means the acceleration of the bob is directly proportional to displacement and directed opposite to displacement, minus sign indicates, which is the condition for simple harmonic motion. Let us compare with standard equation. A is equal to minus omega square y, where y is the angular frequency. From that we got y as omega as root of g by L. Okay. Since omega is 2 pi by t, t is equal to 2 pi root L by g. This is a very popular formula for time period of a simple pendulum. T is equal to 2 pi root L by g. Okay. For any system which is an SHM, you have to prove first the acceleration is proportional to displacement. That proportional constant equate to omega square. From that we can get the time period equation. Okay. Let us see what type of questions they may ask in competitive examination on these systems. Let us see what type of questions they may be asked in competitive examination. Usually in board exams like IP examination or a CBSE board, usually they try to ask, derive this time period of simple pendulum and all. In competitive examination, they may ask like this. Let us say there is a simple pendulum whose time period is, let us say, 12 seconds. Time period is 12 seconds. Okay. Time taken to complete one oscillation. To go to extreme position, the right extreme position, the mean position, right extreme position, again it come back to mean position, left extreme position and mean position. The time taken to complete from here to here, as you know, that T by 4. T by 4, T by 4, T by 4, T by 4. So 4 into T by 4 T. But usually they ask how much time it takes to travel from mean position y is equal to 0, from mean position y is equal to 0 to y is equal to a by 2. That is, from mean position to middle position, how much time take. But usually the student make a immediate approximation. Since y is equal to 0 to y is equal to a, it is T by 4. So since displacement is half, T by 8 they write. Usually that is a silly mistake, they do that. Okay. But actually, since the bob is not moving with the uniform speed or uniform velocity, its velocity is varying, but be careful. Okay. So to calculate the time to travel from mean position to the middle position, okay, we have to use displacement equation for SHM. That is, y is equal to a sin omega t. Since it's starting from mean position, I am using the equation y is equal to a sin omega t. If it starts from extreme position, I have to use y is equal to a sin omega t plus 90. Okay. Extreme position. Since it's starting from mean position, I am using my sine function. So what he is asking is, what is this t when y is equal to a by 2? So substitute y is equal to a by 2. So we get omega t is equal to so half sin omega t is half, omega t is 30, that is pi by 6 radians. Sin omega t is, because a gets cancelled, omega t is sin half. Okay. But we know that omega is 2 pi by t into t is equal to pi by 6. Pi gets cancelled, t is equal to, small t is equal to capital T by 12. The time taken to travel from mean position to the middle position is T by 12 only. It is not T by 8. So from here to here T by 12, from remaining is T by 4 minus T by 12 is T by 6. T by 12, it is T by 6. If I add these two times, I should get T by 4. And be careful, this type of questions usually they ask in a competitive examination. That means in the first half it takes less time, second half it takes more time. As you know that in SHM, the velocity at mean position is maximum, the velocity at extreme position is 0. Extreme position. So as it moves from mean position to extreme position, the velocity goes on decreases. That's why first half takes less time, second half takes more time. So this type of questions usually they ask in competitive exams. Let us take one more very important simple harmonic system is, which is very frequently asked, is spring mass system. Spring mass system. What is this spring mass system? This system consists of a spring of constant K connected to some mass M. The system consists of a spring of constant K connected to a mass M. Here, what is this K? The very important is K is defined as force required to compress or extend the spring by 1 unit. The definition of K is force required to produce unit extension or compression. Maybe unit extension or compression. K is a constant for a given spring. It depends on the number of turns, length, material and all. For a given spring, it is constant. So, force F is equal to Kx. So, sometimes you can say this is a Hooke's law also. So, now this mass come to an equilibrium position. From equilibrium position, we extend the spring by x. This x may be displacement for this mass. Then the restoring force developed in the spring is Kx. The restoring force developed due to elasticity of the spring is Kx. If displacement is down, the restoring force is up. So, I can write the restoring force acting on this mass is F is equal to minus Kx. Here x is called displacement of the mass. F is the restoring force acting on this mass. According to Newton's second law, F is equal to ma. Then the acceleration of this mass is minus k by m into x. The acceleration of this mass is minus k by m into x, where x is the displacement from the mean position, which is the, again if you look at the acceleration is directly proportional to displacement and directed opposite to displacement, which is a fundamental condition for simple harmonic motion. So, how do you find the time period? We know that A is equal to minus omega square x. A is equal to minus omega square x, where omega is root of k by m and the time period of SHM is 2 pi root m by k. These are one more important simple harmonic system is spring mass system whose time period is 2 pi root m by k. So, once we discuss simple harmonic motion systems, let us find out their kinetic energy and potential energy of simple harmonic oscillator.